Welcome here. Thank you for being here today. My name is Venu Aravamudan. I am a Senior Director in Product Marketing at VMware. And today I'm also joined by two other gentlemen from Lone Star College System, Link Allender and Corey Bradfield as well. And just a couple of logistical things. I'm going to provide you an overview on business continuity and disaster recovery here today. This session is intended to give you kind of the broad look at all of the different technologies and capabilities that VMware makes available to you in terms of looking at business continuity within a site as well as across sites. So this is kind of a higher level overview of those technologies, how they fit, how they compare and contrast, and things you can do with them. I hope to spend about 35 minutes on that, and then Link's going to come up here and talk about, I'm the theory side and he's the practice side about the real world implementation that they've had at Lone Star College for SRM for business continuity. And then we'll try to leave a good 10-15 minutes for Q&A in terms of questions. Cell phones, pagers, please turn them off. And then when we do get to the question and answer session, I'd appreciate it if you could walk up to the microphone here. It'll make it easy for everybody to hear. I will repeat those questions again. But if you could do that, that'd be great. Okay? So with that, let's get started. Standard disclaimer. So let's first talk about what VMware does for business continuity, and we kind of look at this in three big pillars in terms of, like I said, data protection, local availability, and availability across multiple sites. So there's some really interesting statistics, right? And this is something that we always remind our customers, which is disaster recovery and business continuity is a very, very important thing to not just plan for and implement, but to also continually test and make sure you're prepared for disasters. Because, these statistics basically, 40% of all companies experiencing a major disaster go out of business if they cannot recover their data and their apps in about 24 hours. And the other interesting thing, as I said too, is that there typically tends to be a little bit of a kind of two sides of the coin where people feel like they have the right plans in place and they have the right recovery time capabilities, but the reality doesn't really quite match those expectations. And we'll talk about some of the things that we recommend to our customers to be able to address that. Just a quick show of hands, I'm curious. How many of you today are still in the stages of planning for disaster recovery? Great. And how many of you today have done any level of evaluation, testing, or deployment with SRM specifically? Just a few. Got it. Okay, thanks. So if you look at the traditional model, right, and this model plays out in many scenarios, but effectively what happens is that the traditional way of looking at protecting these mission-critical applications has been a lot of siloed implementations. These implementations tend to have very application-specific constructs behind them. They're built on very kind of customized stacks of technology typically. You need highly skilled staff to be able to work with these. And also the risk of errors compounds because you're dealing with multiple, again, silos when you're trying to recover things at a different site, right? And in some cases, some of these technologies like MSCS, Oracle RAC, they've been around for a long time, and a lot of customers will continue to use them for a long time. Again, the point that I hope that you get across as we walk through the VMware capabilities are that we provide a lot of normalized capabilities for disaster recovery as well as business continuity within a site. And over time, we hope to reduce the complexity and eliminate the need to have these complex silos in place. So when you look at, again, the three big pillars in terms of business continuity for all applications that we provide to our customers, there's kind of three major themes to this. The first is around local availability, and I'll talk a little bit about the capabilities such as VMware HA, high availability, fault tolerance, vMotion as a technology. There's basic data protection capabilities, and we'll talk a little bit about VMware data recovery and what it does in terms of being able to protect your data, as well as the work we do with our ecosystem partners around providing what are called vStorage APIs for data protection. And then we'll talk also about DR across sites using things like VMware SRM and also highlight metro clustering, which is becoming more popular in the last 12 to 18 months. Okay, but the big main point here again is that all of these technologies are agnostic to applications and operating systems, so they're fairly independent, and they focus on simplicity, out of the box capabilities to be able to give you a very strong level of protection. So this is a fairly recent survey we did in January of this year, and we asked the customers. There's about a little over 1,000 customers that responded to the survey about the top 5 objectives as to why they're looking at virtualization and what kinds of problems they're hoping to solve. And the number one standout was that virtualization gives you this great ability to first, forklift all of your applications above that infrastructure, and then gives you the mobility to be able to, provide business continuity and disaster recovery, with much faster turnarounds in terms of recovery time objectives. So we spoke about these pillars of data protection, local availability, and disaster recovery, but the first thing I want you all to note is that this is built on a very reliable platform, which is the vSphere platform is really designed, first of all, in itself to be very resilient from failures in any one mode. For example, a NIC fails, a storage controller fails, you lose one path to storage. Right? The first thing to notice is that we've built in a lot of resiliency in vSphere to be able to deal with these single component failures taking down a system, right? It's also a very, very stable platform. We've had customers literally running ESX instances for over 3 years in terms of continuous uptime. And then lastly, with our move toward the ESXi architecture, we're moving toward a much smaller footprint for the vSphere platform again, which again makes it a lot less likely for something to go wrong in terms of system issues. So the first thing is, vSphere in itself has a bunch of built-in mechanisms to deal with things like component failures and single points of failure. In terms of data protection, we have a very well-published set of APIs called the vStorage APIs for data protection. And these enable our backup partners and our ecosystem to be able to provide much more advanced capabilities around backing up virtual machines, the data that these virtual machines depend on. And these are very non-disruptive to applications and users. You can enable really powerful scenarios such as off-host backup, off-LAN backups. You can enable image level, file level, backups and restore type scenarios. And these are also fully integrated with technologies such as volume shadow copy services, which give you the application quiescing, where the where your backup application can request the application. Let's say you're running a SharePoint, you're running Exchange, SQL Server. It can actually integrate with the VSS framework and say, hey, I want this application to quiesce for an instant while I take a snapshot before I do my backup. And when you do that, the snapshot that you take is what's called application consistent as opposed to just crash consistent. Okay? And that gives you a very application consistent copy of the data that you just backed up. So we provide all these abilities and these APIs, and we have a very rich ecosystem of just about anybody who's anybody in the backup management space, and all of these different products and companies integrate with those APIs to provide kind of very robust enterprise class solutions for backup. We also have something out of the box in terms of what we call VMware Data Recovery. This is kind of the next version of what we used to call consolidated backup. And VMware Data Recovery is a simple tool. It's optimized much more for the VI administrator as opposed to an enterprise backup administrator. It's built into vSphere, and it's an agentless disk-based backup. So this is only to disk, not to tape. And it still provides you VM off file level restore capabilities. So the granularity is pretty good. Provides incremental as well as full capabilities. Basically one appliance can back up to 100 virtual machines, and you can go to up to 10 of those for a given vCenter instance. Okay, so this is really targeted at small to medium enterprises, and again, it's targeted around those customers who want to have a VI admin focused, very simple, few steps backup scheme, as opposed to the much more full-blown products that are partners such as Symantec and Commvault and everybody else does. Let's talk about local availability. So the first thing that we have in the platform for local availability, this is another level of resilience, is basically vMotion and DRS maintenance mode, right? So if you want to put a server into maintenance, you want to do a hardware upgrade on a given host, what you can do is that you have the ability to be able to vMotion virtual machines off of the host to another host in the cluster, and to be able to deal with things like hardware upgrades and other types of maintenance. And this gives you the ability to move virtual machines, and we also have what's called storage vMotion available, which is the ability to move LUNs from one array to another without any application or user impact. And these technologies, again, they come as part of vSphere, and they give you the ability to deal with planned downtime so that you can keep your systems and your applications and users up and running. Now, in terms of unplanned downtime protection, what we have is we have a VMware high availability option, which gives you the ability to restart virtual machines on any other available host in your cluster, so that once again, here you do take a restart. So what happens is that your host goes down. Let's say you got 10 VMs, and then based on a load balanced cluster, these VMs get started up on other available hosts. But it's an actual VM restart, so you have some amount of downtime before those virtual machines come back up. But it does give you a basic level of protection against unplanned downtime effectively when something happens to the host that your virtual machines are running on. But the nice thing again is this is also OS and application agnostic, so it gives you a very broad range of protection for just about anything you're running on a virtual machine. Recently, in version 4.1 of vSphere, we introduced something that goes one step beyond this. So the basic HA is not what we call application aware, right? It gets triggered when the host goes down. Now, we introduced this new technology called application aware HA, which is a set of APIs that our partners integrate with. And how this works is as follows. You have an agent that sits in the virtual machine that's monitoring the health and state of the application. So let's say you're running SQL, you're running SharePoint, a web server or an index server for SharePoint. And you could have an agent that's sitting in the virtual machine that is aware of the health and state of that application. It might even know things about the application being in a good state, not so good state, trending toward a bad state, things of that nature. And what happens is that when that agent detects an application issue in the virtual machine, it will try to restart the services that the application provides. And it'll try that so many times to see if it can successfully stop and restart those application services in the virtual machine. In the worst case, if it detects that it's actually hung, you can then trigger an actual VMware HA event again, a high availability event, and restart those virtual machines on a different host altogether, okay? So this is what's called application aware HA, and it brings, like I said, a certain amount of application awareness to what's going on to be able to, again, be resilient to application failures. And so we had Symantec, for example, announced their version of a solution based on, I believe the product's called Symantec HA, based on this technology. And so now there's a solution in the market. We're working with many other partners to leverage this infrastructure to provide application awareness on top of basic HA. Okay? We also have this capability called VMware fault tolerance. And you can think upon fault tolerance as something that is zero downtime and zero data loss, where you've got virtual machine running on one host where you're running your application, and then you have a second virtual machine on another host in the FT cluster, which is in complete lockstep with this initial virtual machine, so that when something happens to your virtual machine and it goes down, you can immediately move over and direct your services over to the virtual machine that's in lockstep with the first one. Again, this is fully integrated with the infrastructure. It's a part of vSphere. It doesn't require any complex clustering or specialized hardware type requirements. It gives you a great level of zero downtime, zero data loss capability. However, to be clear, today this is limited to one vCPU virtual machines. And VMware is working on an SMP version of this. It's part of a roadmap. Can't make any promises as to when that'll actually surface. But we are working on the ability to scale this up to kind of SMP type environments as well in terms of your virtual machines. But once again, the other common factor is this is independent of any applications and operating systems, which is nice. Let's talk about disaster recovery now. So traditional disaster recovery, right, when you think about trying to take your applications and your infrastructure that's running on a given site and try to bring these up in a consistent way in another site based on a disaster or some type of an event that takes out your primary data center, these processes tend to be extremely complex. They're very manual processes. You almost create, these red books that are like this thick in terms of the series of steps you got to go through and everything you got to take care of. You need perfect training and documentation, execution, and there's just a lot of inherent risks in terms of how this is traditionally done, right? And the consequences of failure to meet those business objectives are that it can be very expensive to implement in the first place. It could still take you days or weeks to recover in terms of what you have to bring up and the whole sequence of things you got to do. And fundamentally, it's a very unreliable process, and it's very hard to validate this because you can't really test this in the real world. I mean, even if you establish this thing, right? And the big difference that virtualization brings is that, like I said, once you have the mobility of these virtual machines and the storage and everything else, you can drastically reduce the amount of time that it takes to recover from a disaster, right? I mean, even for the smaller data centers, where it would take you 24, 48, 72 hours to recover, what virtualization does for you is gives you the ability to cut that down to like a matter of hours if you've got a good framework to design your disaster recovery and to test it on an ongoing basis. And you can really eliminate a lot of the recovery steps in terms of you don't need to be reinstalling operating systems and applications and configuring them and all that stuff, right? Because you captured all of these in virtual machines, which are very well encapsulated. So, there's many layers to how you approach this problem, right? The first thing is that, you can look at getting storage replication in place just to move your data across sites. And that gives you, again, a basic level of resiliency. There's something called host-based replication. Typically, storage replication solutions are very dependent on, a storage vendor, and there might be a lot of requirements around some level of uniformity around what storage you have on site A versus site B. Now, we are working on something called host-based replication, which will probably address the needs more of our mid-market customers. Again, many of our enterprise customers are very happy with their storage vendors, and they have, storage arrays on both ends, and they have a good infrastructure in place. But host-based replication is something that we're working on as a next step to be able to provide replication based on just the virtual machine hosts, and to be able to move that information across sites. And you can also have a certain level of application consistency that can be provided by your replication vendors based on, again, frameworks such as VSS for application quiescing and application consistent snapshots and then movement of data, for example. Now, we introduced Site Recovery Manager a few years ago, and this is a great product, right? I mean, this has been a very, very successful product for VMware, one of the fastest growing products that we've had. And its value proposition is very simple but very powerful, right? What it does is it helps you automate those recovery processes. You can create these orchestrations, and you can capture all those, detailed, 2,000-page runbooks in a set of processes around how you sequence and how you drive your workflow for recovery. You can ensure a very predictable recovery time objective, right? And it's built on this very strong foundation of being able to do non-disruptive testing. This is probably one of the largest value adds in that you can test your DR plans, and you can do this on an ongoing basis, right? So that at the time that a disaster actually strikes, you're confident that what you have in place will actually work because you've tested this thing, right? And you can test this thing on an ongoing basis because, even within a primary site, as you bring on board new applications and new processes and new things to recover, this gives you a framework where you can do this testing periodically on an ongoing basis. It's something that we really stress to our customers, that a DR plan is not just created one time. You have to be testing this process and ensuring its validity, on a frequent basis to make sure, again, that when you do get hit by a disaster, you're in a good shape to recover. And finally, SRM provides you kind of the centralized management from the vSphere that you kind of know and you're aware of. So it gives you a way to manage, all of your different DR schemes. And as I said, this product has tremendous momentum. We've got over 3,500 customers now, a very significant year-over-year growth in terms of the number of customers that are starting to adopt this product and deploy it. Again, just based on the simple but very powerful value proposition it brings to be able to cut down your recovery time and to give you a very predictable framework for disaster recovery. So if you kind of compare and contrast, traditional DR solutions, which are based in the physical world, versus something as basic as just relying on replication to give you some level of resiliency in terms of disasters, and then what SRM does in combination with replication, right, from our storage partners. This is kind of a quick matrix overview. Effectively, traditional DR, you don't get encapsulation. You have a lot of hardware dependencies across those sites. You don't get any consolidation benefits. You can't really automate those runbooks. You don't really have a reliable RTO because you can't test this thing in any meaningful way. If you want to do testing, by the way, it is going to be disruptive, and you don't have a kind of centralized framework behind this, right? Once you introduce basic replication, you can do some of these things, but you still don't have the automated orchestration, workflow, sequencing, all of that stuff, the testing framework. It's still not, it's not really predictable because just based on replication, you can't have a predictable scheme. But what SRM gives you is all of this, right? Again, the key things here to note is a framework for defining your workflows and your orchestrations, very non-disruptive testing to be able to ensure that you can meet your recovery time objectives, and kind of a centralized management scheme behind planning and managing your disaster recovery processes. So some of the futures in terms of SRM that we're looking at, as I said, is today we work very closely with our what I call storage replication adapter partners, and just about every major storage vendor works very closely with us to give us the replication for their given arrays. But we're also working on, as I said, a host-based replication capability, which will be part of the vSphere, in terms of being able to not have to rely on a third-party replication process. We are also looking at supporting what we call long-distance vMotion, the ability to be able to vMotion across very large distances with the same experience you have today. And then finally, we're also looking at the DR to the cloud model. I mean, imagine that you could provide disaster recovery as a service through some of our vCloud service provider partners, and to be able to leverage that service with well-defined SLAs around that for a set of virtual machines or applications you want to protect. So that's certainly a place that we are looking at and working closely with our partners on this front as well. So these are all some of the future directions we're taking with SRM on a go-forward basis. Again, effectively, what we do with this is that we start becoming more and more of a site manager, because these are different ways of solving the same problem, which is fundamentally you want to be able to bring your applications and your data back up as fast as possible when disaster strikes. And effectively in that model, SRM becomes more of a site manager for you in terms of planning those schemes and being able to deploy the right protection schemes. There's multiple deployment topologies. Kind of the traditional ones tend to be a one-to-one mapping between the primary site and the recovery site. There's also another model that we support where you can have multiple sites that are being protected by one common recovery site, which can be leveraged better for things like branch offices and those types of topologies. But again, we support many different flexible such topologies in terms of disaster recovery planning, and these are all they meet different sets of business objectives. When you look at SRM, right, one of the key things is setting up what we call LUNs and protection groups, as well as what we call consistency groups. And really what this is all about is that it's about the granularity of protection that you put in place for each protection scheme effectively, right? So you got to think about what's the smallest number of applications you want to recover in one shot. You want to think about things like, hey, what are all the different LUNs and database groups that you want to create behind these protection schemes, the data store groupings. When you think about something like Exchange, for example, right, you have to consider that, you got infrastructure services, obviously, things like Active Directory and so on, but even beyond that, within Exchange itself, you got to think about the CAS server, the hub server, the mailbox server, and think about the groups of application components that are part of a given protection group, for example, for protecting Exchange. So these are all different kind of architectural things that you think about when you create what we call recovery plans, right? So you think about putting these things into the right groupings, the right protection groups, and then define the scheme for each one of those protection groups, right? So it's just, there's a lot of kind of detailed methodology behind these. We have a few other sessions in this track, in the business continuity track, where folks like Michael White go into the best practices behind these. But again, I just want to point this out in the context that SRM gives you a lot of granularity of control, but a lot of how well your BCDR schemes actually work out depend on how well you plan for this and how well ahead of time you look at your applications, your databases, your LUNs, and define these different protection groups and protection schemes. It has a lot of impact in terms of how effective you are in terms of both recovery time as well as recovery point in the case of a disaster, right? So these are things that are, again, at a high level that you need to consider, plan. Planning is a very key component of coming up with a successful scheme, but SRM gives you the tools to be able to deal with multiple levels of granularity and different levels of protection groups and groupings of these applications so you can come up with the right schemes. Testing, as I said, one of the biggest benefits, right? What you can do is you can create a very isolated test environment by snapshotting and replicating the LUNs, the data before your test, creating your virtual machines and taking snapshots of these things, fence them in a separate network segment, and then be able to effectively automate your test execution against your plan, and then to be able to ensure that your testing processes, your workflows, your orchestration actually work like they should in case of a real disaster, right? And then to be able to rapidly reset the environment right after your test so that you can kind of power off and delete, and throw away resources you don't need anymore. But the thing is that it's very non-disruptive testing, and you can incorporate existing, kind of tools and processes. And as I said earlier, this is very, very important for our customers to do this on an ongoing basis, because if you don't do this on an ongoing basis, again, you're going to increase the chances of errors and other things happening when a real disaster strikes. But this is a great tool. It gives you all these abilities, and it's very non-disruptive, so there's no reason not to do this to be able to ensure that you have a good DR plan in place. And what actually happens when this is a snapshot of a console, and for example, you can look at the different steps of the recovery plan. You might say that some of these steps you don't want to execute in the test mode. You can look at the status and the timestamps of these different steps as you run through your recovery plans in your test infrastructure. When these steps actually executed, the user confirmation messages about a particular step being successful or not. It gives you a lot of detail, and again, a great way to validate your overall DR scheme and make sure that you have something that you can depend upon. And effectively, the failover automation process is very simple. You get a failure on a given site. You need to make the business determination that you have an actual disaster event in your hands. You trigger the whole process around failover. You get to use a confirmation of the outage. You can start doing granular failover initiation using SRM, and you can manage the replication failover and effectively execute all your recovery processes, right? And we also have today a manual way to fail back, from your recovery side. One of the things we're working on in the next roadmap is to be able to do automated failback from your disaster site back to your primary site when you have the backup and running. In terms of how this product is licensed, we had a few changes I want to highlight. So traditionally, SRM was licensed on a per VM per proc basis, effectively. I'm sorry, on a per proc basis. We introduced a per VM, per protected virtual machine licensing model recently. There's a period of time until which both of those models are actually available through about mid-December of this year. After that, we move over to only a per VM model. And we actually believe it brings a lot of benefits to our customers, primarily because in the previous model, effectively what happened was that for SRM protected virtual machines, you'd find a dedicated SRM cluster in most implementations because we were licensing this on a per proc model. But in the new model, the nice thing is that you can just look at which virtual machines are actually being protected by SRM, and that's kind of independent, and those are the ones they're licensing SRM for, but that's independent of the actual, you're not actually tied to the processors that you're licensing effectively. So this is more of a flexible kind of a pay-per-use model where the cost is directly related to the utilization, and you don't need to do artificial things like having a separated cluster just for your disaster recovery schemes. Okay. Metro clustering, I just want to highlight this. This is kind of a becoming more popular amongst the customers. We've seen more adoption of solutions from EMC and NetApp type partners. You can think about it as, just like a stretched vSphere cluster. You take a vSphere cluster across like a large metro area and you stretch it to like, 60 miles, 100 kilometer type distances. Typically has an active storage cluster. has some level of automated protection through VMware HA and vMotion across those two sites, and you get the data replicated as well. It's just something I want to highlight. It's very similar to other kind of replication-based solutions. Again, it doesn't give you a lot of what SRM truly gives you in terms of true runbooks, orchestration, workflows, the testing framework, and all of that. But it's still a solution that some of our customers have been evaluating and deploying a lot more in the last 12 to 18 months. Okay. So with that, some quick next steps. As I said, the biggest key to a successful DR and business continuity strategy is to have a good business impact analysis. Really think about the different tiers of availability that you want to establish. Think about your recovery time, your recovery point objectives across the applications that you're protecting in your infrastructure. Think about this application dependency mappings, the protection groups, consistency groups. Think about, what are the services you need to bring up first, the weakest links in your chain, the Active Directory services, DNS, DHCP, those types of services, and come up with a good business continuity design that maps back to those objectives, right? And you got to budget this ahead of time, plan ahead of time, and most importantly, test the stuff, right? Because SRM gives you a great framework to design these schemes and to test these schemes, and again, map the results of those tests back to your business objectives to make sure that they meet what you have for your business objectives, right? And we have a bunch of VMware professional services offerings, as well as our partners provide a lot of these services around BCDR planning and implementation effectively, So with that, just a few quick links where you can find more data on the product page, solutions and best practices and other such collateral on our website, and technical resources on BCDR, as well as some external resources that are pretty popular in terms of best practices. So, and we have the partner locator as well, which is a great tool to identify partners who can help you with BCDR planning. Okay. With that, I'm going to turn this over to Link from Lone Star College to talk about a real-world implementation. And then I'll come back when he's done, and we'll take open Q&A after that, okay? Here you go, Link.
Thank you. I actually learned something during that presentation, and we've been doing this for a while now. Let me figure out which clicker goes where. Okay, first off, I want to talk about who we are and what we are, because I think it's important to put that into perspective. You think a college system is rather small. In our case, right now, this semester, we're just now opening up. We're looking at 90,000 students. We're located in the North Houston area across a large 1,400 square miles. So providing the high availability services in that challenging environment. The other part is, while we only have 4,800 full-time employees, we also get 6,000 plus adjunct instructors that step into our doors every semester. So they may have been with us before, they may not have. They present a challenge in taxed our resources each time through. So sorry about the 80,000, it's a little out of date. We had a good year again. Really good year, actually. Okay, part of this that I want to talk about here, though, is how we got where we're at. 2 years ago, we had a new CIO come in, reorganized everything. All of our IT organizations became one. We were disparate prior to that. And in that process, one of the first things he said was, we need a 5 nines infrastructure. So how many here can say you have a 5 nines infrastructure? Excellent, excellent. How many colleges have a 5.9 infrastructure? That was my first comment. Been in the university and college space for a long time. So that was the first challenge we had. The next one is we had decaying infrastructure. I was actually on a campus at the time we centralized, and we're looking at outdated SAN equipment, no really forward plan for our data centers, outdated hardware across the board. So we started looking at redesigning the enterprise. In that process, one of the first things we did was we moved into and said, we're going to do a VMware ELA, we're going to get an all-you-can-eat plate, we're going to redesign our back end, our storage infrastructure, our network infrastructure. We're going to go down the pipes. We're going to redo everything. But the biggest one was put a VM first policy in. If I'm going to have to provide 5 nines for my Tier 1 applications, what's going to happen for my Tier 2 applications and my Tier 3 applications? So we had to rebuild everything from scratch. So basically, in under 18 months, I had the privilege of going through the process of redesigning network, redesigning data centers, and providing this high availability environment. So one of the things I want to point out on this is how we're structured. We have 14 different locations right now, and we're adding another 3 this fall through this spring, 3 different sites into our mix. So each campus site has its own virtual solution. All those virtual solutions can come back up to my main data center. We use storage virtualization to be able to move the data across, the VMs. At the same time, in our main data center, we have 2 major VM farms that basically co-locate and replicate the process across. We also have virtualized our Tier 1, our ERP. We're getting ready to move a few more Tier 1 applications into virtualization space now. So in this whole design, we have the ability to fail over from site to site, to bring sites in, and go through the entire process, well, let's see, in most cases, a couple of minutes. So here's what we did in our design. We turned around, we said the primary data centers, we're running C7000s with 490s in them. We have an EMC Clarion back end. And on the campus solutions, we put in C3000s because with that combination, it really met the server, the instructional need they had, the utility functions and specialized applications. But then it allowed us to leverage the HP 4500 virtualized SANs. Made it a lot easier to replicate the VMs internally between each other from a center to a campus or the campus to our primary data center. In the centers, instructional centers for us, I'd say are relatively small, but some of them have 3,000 to 4,000 students in them, so they're not exactly that small. We put in the DL380s, and we tied them back to the main campus. We use storage virtualization across those 380s, but by tying to the main campus, then the IT support that's in that area also can provide that assistance as we fail applications back and forth. We did have an interesting test of our DR by accident rather recently in this process too. We went through a water main that broke in the middle of one of our main campuses, and nobody knew how to shut it off. 12-inch chilled water pipe running through the center of a building flooded the data center. We had to shut it down, but we were able to bring all those services, at least the core services they need to operate in the campus and to continue to function, out of our main data center immediately. Okay, so a little bit about what we did in our process of this. We went through a phased implementation. First off, we started off on the systems office, made sure we had the core ready to go, started to build out the campuses and move all those physical servers into the virtual space. Prior to this, we were only 5% virtualized. Right now, we're 82% virtualized. So at the same time, we continued to build out the primary data center, but really, it was a combination, not just the architecture for the server farm, but it was also getting that storage capacity. Interesting comment I heard the other day was for every $1 I spend in VMware, I'm spending $5 or $15 in hardware. I have to agree with it now. I never heard that number before, but the reality is to create that high availability, the back end has to be beefed up, has to be strong. The campus and center server storage refresh, what we did basically is we had, like I said, a lot of outdated equipment in the process. So we went through a process of evaluating what was worthwhile, what we could reuse, which wasn't much, but then brought them into the fold at the same time. We had an interesting acquisition not too long ago. If you read the Wall Street Journal, you heard about the deal of the century. It was us acquiring a very major portion of Compact, HP, but Compact. We bought the North Houston campus, 7 buildings, 1.2 million square feet in there. And we had to redesign and bring that in line. That's where our new data center is sitting at right now. So we were able to, at that same time, stand up a whole new location, a whole new site, which is a university partnership, and move a data center in, create the availability that we're looking for. After these 2 parts were completed and we had our Tier 1 applications virtualized, we went then into the SRM implementation, which now has been, I do believe, about 2 to 3 months as far as live. I have the technical expert in the audience, so it's, as you can tell, not me. The next part there, of course, was critical, is automation. We don't have a 24/7, we're sitting there all the time, so we had to rely a lot on automation. How can we take high availability, the other tools and other partners that we work with, to guarantee that as the monitoring is correct, that we're failing it over when we need to. So what we really came into out of this in the end was a truly centralized management of our server and data centers from a totally decentralized environment in under 18 months. So now we have one single pane, we can look at it, we can see what's happening out there, make sure formal change control is happening at all levels, which is critical, of course, to any availability. We're able to maintain the VMware level while our server admins have the flexibility to do what they need to do and provision and maintain the systems for the local campus. Along with that, we implemented proactive monitoring. Very big fan of vFoglight. That was there prior to vFoglight acquiring it. To manage and view that infrastructure and how we can make sure we're proactive about everything we do. As long as you can keep an eye on what's happening at least get notified without having to go to a console every 2 seconds, we're able to provide that next level of availability. The biggest one right now is continuity and capacity planning for us. We've already had to expand our ELA shortly, not even a year after we first entered into it. We thought we had understood really what we had, but as we consolidated and got our hands around items, as we decided we were moving into PeopleSoft for our ERP, we decided to go completely with VMware for the platform build on it. So we had to go up through that process immediately. So we're constantly tracking our capacity. What are our capabilities? What can we do? Making sure that whenever we build a system out for high availability, that the exact same capacity is at the other site. Now, that doesn't mean we run everything from one site and we wait for it all to fail. What we do is we run in whatever space is out there. So we just have to make sure at the same time we can bring servers back and forth accordingly. So while it may seem like we're not using our full capacity, a lot of times that's cold capacity at another site sitting there at the ready. Some of the things that really came out of this for us that really helped out, standardized templates, of course, standardized server provisioning. When you take that many organizations into one, for any of you in the corporate side have had acquisitions, you know you bring in all kinds of other technology along the way. It was almost the same thing for us, and while we were a college system, we just were not managed the same way in IT. The centralized monitoring and reporting really allows us to respond immediately to items that would be a day later. Sometimes if an instructor teaches with one application, needs it off of the server, and that server was down, you wouldn't know until that instructor came back into class. Now we know immediately. Whether that's a Tier 3 application, we still know that it's available, functional, and ready to go. The high availability services are our standard. We have not really an option to it. Anything that's in a Tier 1, of course, at 5 nines, but that makes a Tier 2 4 nines. We have a lot of Tier 2 applications. We have tons of them. Eliminate our future capital expenditures. This was straightforward, and I actually put the bank on this one. When I first brought this out as we were doing our VMware assessment, our CFO said, yeah, that's not true. And I said, fine, I'll bank out $600,000. So our CIO and myself sat down with her and said, straightforward, here it is. We need this to put it in place. If I can show you that I would actually have replaced that hardware with physical hardware, made the changes, and spent that cash after 1 year, if I can prove to you that would happen in the process, yet we provided the exact same level of service on newer hardware and updated, then we'll get the additional dollars. Now, the state of Texas is hurting like every state as far as education goes. We took a 5% cut. This year I got those dollars and some because it was easy to show in the end. By centralizing and consolidating, we've been able to reduce those capital expenditures. All right.
Thanks, Lee. So I guess at this stage, open floor up to questions. Happy to take them. Again, if by any chance you could walk up to the microphone there, it might make it a little bit easier for everybody else to hear.
Mixed servers?
If you could repeat the question, that'd be great.
Yeah. Okay. So the question is how many mixed servers in our environment? Actually, Corey's here for that, but pretty much it's fairly standardized. Fairly. Go ahead, Corey. Yeah.
Sorry. Windows servers right now, just a little over 600.
Question?
What kind of resources and technology are you using for your replication?
We're a pure EMC backend as far as our core Tier 1 applications. So there's a recover point, and of course, replication manager. Yeah, I guess you have the expert over there. I just pay for the stuff, but they tell me what they want. then they got to prove it works afterwards.
Yeah. Anything that's running at the primary data centers is recover point replication manager. Anything that's out at a campus site is using all the storage is HP left hand. So they have the built-in synchronous replication between nodes and then asynchronous replication at remote sites.
But what kind of bandwidth do you need to support that? Are all the campuses on Metro Ethernet? Are you one big fiber link or
10 gig
10
dual?
gig?
But we had 1 gig when we implemented this. We just rolled out 10 gig this summer. So yes, we have bandwidth.
This is more generic for SRM. I'm completely new to the product, but what keeps going in my mind is when you're failing over from one site to another, and you've got servers with in a certain IP space with IP addresses, I'm not certain how that's going to work with just failing over and having them immediately available and being able to route to the network that it thinks it's in.
Yeah,
can
so
you
there's a
address-
series of best practices around how you effectively redo your network infrastructure as well. And there's a lot of detail there. Again, I would strongly recommend there's a session by Michael White where he goes into a lot of those details. But you're right, it takes a fair amount of orchestration to bring up those infrastructure services first before you start bringing up all of your applications and other value-added services. So there's a whole series of best practices behind that, which are part of your recovery processes that you automate. So, any other questions? Question is, do you have a timeline for host-based replication? My finance team will kill me if I gave you a committed timeline. It's definitely in our roadmap. It's something that we are very excited to be working on, but I can't commit to any timelines.
Michael White said about a year.
Okay. Michael White said that, not me. It's great. Any other questions?
Rack. Yeah. Or sometimes you don't have a choice. In our case, we just rolled out the PeopleSoft ERP for our organization. And in that process, we have virtualized the app server, the whole made core of PeopleSoft, but the database servers are all physical and they're in the rack configuration. So we had no choice in that matter. We're actually been reviewing right now to move to the next tier 1 application, which would be in our Exchange cluster, into VM completely. And as we go through that process, we'll be evaluating every option. But if we can avoid it, I'd prefer, like I said, in this case with rack, we have to have somebody that really knows rack inside and out. And at the same time as our server admins truly have to understand how rack is replicating that data. And even though that occasionally when I lose app servers on one side, they jump over to the other side because they're running. Half of it runs in one data center, half of it runs the other data center. Okay, so then the capacity is designed so that while there's a core system here on side A and another core on B, if an app server is down over here, it can come up on this one and then point back to its database on the other side because it has to talk only to its original database. So we're trying to lessen that confusion in that process, and we expect the same thing with Exchange. They do have a really good white paper VM has on virtualizing Exchange.
Yeah, I'd like to add to that too, which is, these things they tend to be somewhat apples and oranges too, depending on what you're trying to do and the level of protection you want. For example, actually in shared nothing architectures like Exchange DAG, right, you can still be dealing with other basic VMware platform abilities around HA and vMotion and so on. When you start getting to like something like MSCS, there are limitations to what, you can do in-guest clustering, but there's limitations to what you can move around or not, in terms of mobility, right? But these are also kind of apples and oranges comparisons to some extent, because when you think about MSCS, right, what you're really getting there is you're getting application awareness, because you have these resource DLLs for Exchange and SQL and so on, right? And then what you're also getting is you're getting a finite set of services being restarted in the event of, the heartbeat failing, right, on your primary, right? Whereas even with app-aware HA that we introduced, you're starting to get something similar, but it's still not quite the same because the granularity of control, the set of services that you're restarting and so on is a little bit different between those solution areas. And again, that's why this goes back to your primary objectives you got to be very clear about is what's your recovery time and your recovery point objective. Once you know those two, you can pick and choose what set of technologies you implement. But right.
And at that point, SRM is kind of cool in that it can't go down to the input, right?
Yeah.
But then we also get the issues of sometimes other vendors won't embrace your solution. And that makes it really difficult for me where it's like, well, even if I test it, even if I know it works, even if I demotion it 1,000 times myself, if the document says we do not officially support this, I can't go to my management with faith and say, I want
Yeah, the support thing's an interesting one. I mean, we find, actually Microsoft's been one of the better vendors in terms of support policy over time for virtualization. They've definitely been ahead of some other large vendors I wouldn't name. But, they came out with the whole SVVP program for, basic hypervisor-based certification, and, all of the ESX versions are qualified under the program. And over time, Microsoft has brought on more and more applications. In fact, they have a whole KB article that lists all those different applications that are supported virtualized. I believe over time, some of the support issues will go away. The reality is what we find is most of our customers who have any kind of a premier support agreement with Microsoft, right? They will take the call, and they will even cooperatively work with us in the back end, because if you're a customer with a premier support agreement, they're going to have to support you. They'll take. Right, great. Any other questions? Great. Well, thank you all for coming, and hope you.